Unit 1, Lesson 6, Note 6, Relations. Represent relations. A relation is a set of ordered pairs. We can represent relations using a list of ordered pairs, a table, a mapping, or a graph. The set of all the first numbers in the ordered pairs is called the domain, or x-values. Similarly, the set of all the second numbers in the ordered pairs is called the range, or y-values. Express each relation as ordered pairs, a table, a mapping, and a graph. Identify the domain and range. So in example A, we have the ordered pairs, a set of ordered pairs. So we have 2, 5, negative 2, 3, 5, negative 2, and negative 1, negative 2. To take those ordered pairs and put them in a table, what I want to do is take all the x values and put them in the x column, and the y values and put them in the y column. However, what I want to do is put them in numerical order. So if I take a look at my x values, I want to choose the smallest one. The smallest one is negative 2. So I'm going to go ahead and start by writing negative 2, 3 in my first row. So negative 2, 3. The next smallest x value is negative 1. So negative 1, negative 2. After that we have 2, 5. And last but not least, 5, negative 2. So here we have our table of values. Next up is the mapping. Now the mapping is indicated by either 2 rectangles or 2 ovals, depending on where you're looking. The left oval represents your x values or your domain. The right oval represents your range or your y values. So all we have to do is list our x values in this box and our y values in that box. The one condition, or 2 conditions I should say, they have to be in numerical order, smallest to largest, and they also can only represented, each number can only be represented once. So here's how we do it. If I look at my x values in the table, they're all different numbers. That's perfect. I can just list them in increasing order in the map. So negative 2, negative 1, 2, and 5. Now take a look at your y values. I have 3, negative 2, 5, and negative 2. Negative 2 repeats, so I only write it once. And they must be in numerical order. So the smallest y value I have is negative 2. I'm going to write negative 2. I'm only going to write it once. The next smallest is 3, and the largest is 5. Now that we have them listed, what we're going to do is draw lines to show the mapping. So I have here, we'll change colors, negative 2, if I look at my table, negative 2 is paired with 3. So all I'm going to do is draw a line from negative 2 to 3. My next ordered pair is negative 1, negative 2. So I will draw a line from negative 1 to negative 2. Next we have 2, 5, and then we have 5, negative 2. It's okay that it goes to the same number. Now to graph. We are going to take our ordered pairs and graph them. So our first ordered pair from our table is negative 2, 3. So negative 2, 3. Let's see if I can get a little thicker here. Negative 2, 3. Then we have negative 1, negative 2. So negative 1, negative 2. And 2, 5, which is up here. And 5, negative 2. And that's how we graph our ordered pairs. Now we need to determine the domain and the range. The domain, remember, is the set of x values. We only write them once. So what's great about doing the mapping beforehand, it's already in numerical order, and I just have to write them. Now domain and range, they have brackets. So domain, we put our bracket here. We have negative 2, negative 1, 2, and 5, and then I'll close the bracket. The range are the y values. Again, look at your mapping, the second column, -2, 3, and 5. And we separate our numbers with commas. Go ahead and do letter B. Letter C. The daily cost of production in a factory is calculated using C of x equals 200 plus 16x, where x is the number of complete products manufactured. Which set of numbers best defines the domain of C of x? So when it's asking for which set of numbers, it wants to know, are you going to use integers, rational numbers, whole numbers, etc. So we are talking about products being manufactured, items. You can't have negative items. Therefore, the set of integers, which includes our negative numbers, is excluded. Think about what you can have. I could have 0 items. I could have 1 item, 2 items, 3 items, etc. I can't have half of a product. I can't have 3/4 of a product. I can't have 0.7 of a product. I can only have the following numbers. The set of numbers that those belong to are called whole numbers. Interpret graphs of relations. The variable in a function with a value that is subject to choice is the independent variable, or the domain. The variable in a relation with a value that depends on the value of the independent variable is called a dependent variable, or the range. So here we go. Identify the independent and dependent variables. The dance committee is selling tickets for the snowball dance. The more tickets they sell, the greater the amount of money they can spend for decorations. So we have to think about which item depends on the other. So we have the number of tickets and we have the amount of money. Well, money depends on the number of tickets sold. If you sell more tickets, you get more money, which makes money dependent on tickets. So money is the dependent variable, tickets is the independent variable. Letter B. Generally, the average price of going to the movies has steadily increased over time. So you're talking about price of movies and time. Well, which one depends on the other? Does time depend on the price of the movie, or does the price of the movie depend on time? Well, the price definitely depends on time. So time is the independent variable, and dependent variable is the price of the movies. Go ahead and try letter C. And what I want you to do for now, I want you to leave the graphic organizer blank on the bottom, which is this right here, okay? And we will do this at a later date.